Hello class, today we're going to be learning lesson 2-4 in our textbook, which is about learning how to use postulates and diagrams. Now we've talked about some postulates before, so let's just go over what it is again. A postulate is a rule that we accept without proof. So you're going to find that there's many things that we just have come to accept, but we can't prove it, all right? But we know that it's true. Whereas a theorem is a rule that can be proved. And in geometry, you guys are going to be working with a lot of both of these concepts, postulates and theorems. But today is mainly going to be using postulates. Now, I said that we've already had some before. So the 4 that we've had was the first one, the ruler postulate, if you remember that. The second one was the segment addition postulate. The third that we've learned about was the protractor postulate. And the fourth was the angle addition postulate. So we've learned 4 different ones already. And by the end of this lesson, you're going to know at least 11 different postulates. So let's go over those. We're going to have some new ones today. Postulate number 5 says this: through any 2 points, there exists exactly one line. Okay, this is something that we've already kind of come to accept, something that we've already learned. So if I have 2 points, there exists exactly one line that passes through those 2 points. Okay? A lot of the ones that we're going to learn right now are based on points and lines and planes. So the second one is very similar, but it is a little different. A line contains at least 2 points. So this time I'm starting with the premise that I have a line, and I can assume that it has at least 2 points on it. We know that a line is made up of so much more, so that's why I'm drawing several different points. Okay? Postulate number 7 says, if 2 lines intersect, then their intersection is exactly 1 point. We've already kind of gone over this. If I have one line, and I have another line, and I look at where they intersect, they're intersecting, they're meeting at exactly 1 point. That's postulate number 7. Postulate number 8 says, through any 3 non-collinear points, there exists exactly 1 plane. So do we remember what 3 non-collinear points look like? It's 3 points that cannot all be put on the same line. And it says that if I have 3 non-collinear points, they're all on exactly 1 plane. So there's only 1 plane in the world that has all 3 of those points on it. Okay. Postulate number 9 says a plane contains at least 3 non-collinear points. So this time I'm kind of going backwards. If I start with a plane, on this plane I can find at least 3 non-collinear points. And I know that I can find much more than just 3. Okay. Postulate 10 says, if 2 points lie in a plane, then the line containing them lies in the plane as well. Okay, so if 2 points are in a plane, let's draw that first. I have my plane, and I have 2 points in this plane. Then the line containing them, passing through it, is also in that same plane. Okay? And the final postulate for today is postulate 11. It says, if 2 planes intersect, then their intersection is a line. Okay, so bear with me, I'm going to try to draw this. So if I have one plane, and if it intersects with another plane, try my best here. then their intersection is exactly one line right here. Okay, they're crossing at exactly one line. And those are the postulates that we're going to work with today. Now you'll see when you do some practice problems that they'll give you diagrams and ask you to state certain facts that you know based on these up to 11 now postulates that you have under your belt. So let's move on to a diagram, which is part of what today's lesson is all about. So I've drawn a plane here, okay, and it has many things going on in it. There's many points. You can see that there's many lines that are already drawn. I know the name of it is plane P, if I just wanted to give it a single letter name. And I want to stress that in a diagram, you can only assume things that are marked. For instance, I can only assume that two line segments are congruent if there's markings to show that. All right? Or I can only assume that two angles are congruent if there's markings to express that. So why don't we go over on this diagram things that we can assume. All right? And let's list those different things out. So looking here, there's so many things that I can assume. Already, because I have all these points on this green plane, I can assume that all points shown are coplanar. All right, that's kind of an easy thing to assume just by looking at the diagram. Something else is angle AHB and angle BHD. So that's talking about this angle right here, AHB, and also BHD. I can assume that those two angles are a linear pair. I can also assume that angle AHF, so that one down there, angle AHF, and angle BHD, this one again on the top, BH all the way to D, are vertical angles. Okay. Let's see here. See this line that I have? I can assume that those points A, H, J, and D are collinear. And I can also assume that line AD, that's this long line across, and line BF, this one right here, that they intersect at H. So all these things are very easy and clear for me to just make assumptions on based on the diagram. But there's other things that I cannot assume, and that's because they're not specifically shown to me. So let's make a list of some things that I cannot assume. For instance, look here at these 3 points, G, F, and E. It looks like I could connect a line there, and so it does look like I could find 3 points that are collinear, but I can't assume that, all right? It could be that one of those points is a little higher than the other two and that they're really not all on the same line. So I can't assume that G, F, and E are collinear. Okay, can't do that. I also cannot assume that BF, that line, and CE don't intersect. Okay. Even though they kind of look like they might be parallel lines, I can't assume that they're never going to intersect. It could be that a mile away, eventually they do meet. So I can't assume that. But vice versa, I also cannot assume that they do intersect. I have no proof that they either do or do not intersect. The only way that I would have proof is if I could actually see a point in the diagram that shows that they were intersecting. Let's do two more things. How about the angle AHB and angle CJA are congruent? That's something that I cannot assume. So this is angle AHB and CJA. So even though they're both on the left-hand side and I know some properties about parallel lines, I can't assume that those two are congruent because I was never told that they were parallel lines. And finally, I cannot assume that AD, that line is perpendicular to BF, which means that the measure of, let's just say, angle AHB is equal to 90 degrees. That's what perpendicular means, that two lines cross and they form 90 degrees. I can't assume it, even though it does kind of look like they cross at exactly 90 degrees. It's just something I can't assume unless there was a marking to indicate that. So this is primarily what we're going to be doing in this lesson, is looking at different postulates, the rules that we know, looking at diagrams, understanding what we can assume from the picture and what we can't. So I'm going to leave you with this. I have one diagram for you. Okay, and on your own, I want you to draw this diagram as best as you can. And of these 6 statements, I want you to decide which ones cannot be assumed by the diagram. Okay, the first one says that A, B, and C are collinear points. The second one says that line EF is perpendicular to line L. The third one says line BC is perpendicular to the plane R. See the little R. Fourth one says that EF intersects AC at the point B. Fifth one says that line L is perpendicular to line AB. And the sixth one says that points B, C, and X are collinear. So tell me which ones cannot be assumed by this diagram, and we'll discuss it in class.